Okay, as a quick review, let's take a look at what observed wind patterns look like. This is that model that we saw in the last lecture that shows the three different circulation cells and the directions that they're blowing. What you guys see is that each cell has a slightly curved path that it takes, right? And that results in this equatorial low doldrums area around the equator, where we have very low pressure and very few winds because they're blowing more or less parallel rather than across. Okay, so why do we have these curves in these wind patterns? And the reason is the Coriolis effect. What you guys, I want you to notice is that in each pattern, we actually have wind curving in the same direction if we look at it from the perspective of where it's coming from. For instance, in the Hadley cell, you can see that in the cell that is north of the equator, if you look, it's curving to the right from the direction it's blowing from. If you look in the cell that's above that, you can see that it also curves to the right if you look in the direction it's blowing from. The same thing is true but opposite in the southern hemisphere, where in the Hadley cell it blows to the left, the wind curves to the left, and the same thing happens from the perspective of where it's blowing from on the cells below it. This is an important thing when we get into how the Coriolis affects and how we recognize it.